Hello, this is John from TC Math Academy, and I have a question for you. Can you count? Now, a lot of you are going to say, come on, Mr. YouTube Math Man. Of course I can count. Watch me count 1, 2, 3, 4, 5, 6, 7, 8. Listen, I know you can count numbers, but that's not what I'm talking about. Can you solve counting problems in mathematics? And typically, a problem like this would be something that you would see like in a first or second year algebra course. Let's go ahead and take a look at the problem. It says, how many ways can 3 students be selected from a group of 10 students? So what we need to be able to do here is count this situation so we can answer this question. Now, here's the deal, right? I'm going to show you how to solve this using a formula. Okay, I'm going to be teaching you some really important things when it comes to solving counting problems. But even if you didn't know any algebra, you could figure this out. Okay, you just kind of have to kind of do it in a more manual way. So, don't just shy away from this question. If you're like saying, there's no way I could figure this out, at least think about it, right? Think about if you had to come up with an answer, how could you do it? Because there's all different sorts of ways to solve problems in mathematics. But what I'm going to be talking about is very, very important for those of you that are learning math at a little bit higher level, like Algebra 1, Algebra 2, etc. So if you know how to do this, go ahead and put your answer into the comment section. I'm going to show you the correct answer, and then we're going to have a nice little discussion on some really important foundational concepts in terms of counting. Also, if you need math help with the course you're taking, test prep, or homeschooling, make sure to check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, don't forget to like and subscribe, as that definitely helps me out. Okay, so how many ways can 3 students be selected from a group of 10 students? Let's go and take a look at the answer. The answer is the following, 120. Okay, so now here's the deal. If you got this right, that is definitely cause for celebration. So let me go ahead and give you a nice little happy face, an A plus a 100%, and multiple stars to celebrate your ability to count. Now, it's also likely that you know a thing or two about permutations and combinations. And if you ever heard of permutations and combinations, these are kind of big math words, again, that you learn, in algebra and beyond. Okay, so if you're like, yeah, I kind of heard of those things. They kind of confused me before, like what's the difference between a permutation and a combination? Well, I'm going to try to clear this up in this video. But if you got this answer, but you did it in a completely different way, that's awesome as well. Okay, so it shows me that you didn't give up and you reasoned through figuring this out. And there are some other techniques, namely using things like counting trees. That's a separate discussion. Matter of fact, if you want to know more about counting, check out any one of my courses, like my Algebra 1, Algebra 2 courses, and probably like more like my Algebra 2 course, because I really get into a lot more detail on this concept. But anyways, let's go ahead and get into this problem. And here it is. So it seems pretty, straightforward, right? So it's like, how many ways can 3 students be selected from a group of 10 students? So let's just imagine here we have 10 students, and we just want to pick, 3 students at a time, right? Maybe this person, and this person over here. So that's one way, right? That 3 students could be selected from a group of 10 students. So here we could also maybe pick these 2 people and maybe this person right there. That's another way. So you can kind of just, do all different sorts of combinations to try to figure out exactly how many ways you could select 3 students out of a group of 10 students. So when you start thinking about this, it's like, well, yeah, this is maybe not as easy. It's an easy question to understand, but it's maybe not so easy to figure out the correct answer. So let's kind of get into this right now. And let's suppose we picked 3 people, this person, and maybe this person right here. And the names of these 3 students were John, Dee, and Sarah. I'm just kind of making something up here. So let's suppose we selected 3 students out of this 10. And so here are our 3 students. We selected John, Dee, and Sarah. Okay, you kind of had to select them one at a time I would say, hey, John, Dee, and Sarah. Boom. That's one way we can, pick 3 students out of the 10, right? But what if we said, you know what, we're going to pick Dee first, then John, and then Sarah. Okay. So we selected the people, our group of 3 in a different order, but does that really change? In other words, are these groups the same? All right. In other words, this is one way we could pick 3 students from this group of 10. But is this like another way that we can pick another way to pick 3 students out of 10? Not really. Okay. We're got to go back to the question. How many ways can 3 students be selected? You're just kind of getting 3 students at a time, right? You're just kind of grabbing some 3. Does it make a difference on terms of the order? No, because really these are the same groups, right? So in other words, if I selected Sarah first, then Dee, then John, well, these groups are the same people. Okay, so in other words, they all represent just one way we could pick 3 students out of the 10. Okay, we're not, the order doesn't make a difference in this particular situation, right? Because these 3 groups are equivalent. So this is really, really, really important when it comes to counting. And here is kind of one of the main principles that I want you to kind of remember when it comes to counting problems in mathematics. So when it comes to counting, the way things happen, right? The way when it comes to counting, the way things happen, I really should put like a comma here, I guess. Order needs to be considered. In other words, does the order make a difference, or order does not make a difference? So kind of going back over here, you can see that the way we have our group of 3 students, it doesn't make a difference. If John came into this little group, this little subgroup over here, and then Dee, and then Sarah walked over, or Dee, John, and Sarah. It's the same group. So here, order does not make a difference, and this is really, really important to understand, especially when you're dealing with a particular math problem. You got to first define, does order make a difference or not? Well, let's kind of get into this further because this is the whole essence of what we call permutations and combinations in mathematics. Okay, so some pretty fancy words, and let's kind of get into it right now. So a permutation is a counting situation where order is important. Order is important. I'm going to give you some examples here in a second. A combination is where the order of selection is not important. So our situation that we're dealing with right now, figuring out, let's kind of go back up here one more time. We're trying to determine how many ways 3 students could be selected from a group of 10. It's not important in terms of the order of the way we get those 3 students. Okay, so order doesn't make a difference. Okay, as I kind of showed you with this kind of example right here, right? So it doesn't make a difference. Order selection, order is not important. So this would be a combination situation, but it could be definitely kind of confusing. But you got to first determine when you're dealing with a counting problem, and you got to really think about it sometimes because sometimes it's not so clear. Is order important or is order not important? All right, let's take a look at a couple examples. So let's look at permutations first. I got an example here, but let's keep our focus over here for now to the left-hand column. So let's suppose I had a question like this. How many ways can we line up 6 people? So, you have to ask yourself, is order important or not important when we're counting how many different ways we can line up 6 people? Well, yes, order is definitely important, right? One person is going to be first, next person is going to be second, third, fourth, fifth, sixth, right? Order is important in terms of answering that question. Let's take a look at another question that's a permutation where order is important. So something like this: how many phone numbers can you make with the numbers 3, 5, 7, 8, and 9? All right, so let's say you have a number like 201, 333, a 9-digit number. I don't know, 2011, right? So how many phone numbers could you make given these? Now, of course, order is important, okay, because the digits have to be in a particular order. So to answer a question like this, you're going to be thinking permutations. Now let's take a look at another example of combinations where order is not important. So maybe we had a question like this: how many ways can you be dealt a card hand, right? For those of you out there who like to play poker or cards, whatnot, of a ace, king, queen, and a jack, right? So how many different ways? Well, again, here, order is not important because maybe the first card you get is an ace, then the second card you get is a jack, and then the next one a queen, and the next one is a king, right? But if you happen to get a king first, and then a queen, and then a jack, and then an ace, it's still the same hand, right? So you just kind of reshuffle these cards in your hand. So here, again, order is not important. Okay, order of selection is not important. So again, first things first, you got to consider the situation and answer, is order important or order is not important? And you do have to put some thought into it because sometimes the situations, are not so clear. But it's going to have all the difference in the world, because if you say, hey, a permutation is a combination situation, or a combination situation is a permutation situation, then you're going to end up with the wrong answer. Okay, so now let's go ahead and get into the mathematics of this. So when you're talking about permutations and combinations, we're going to be using the language of permutations and combinations. So there's a couple different notations that you can use. This is a real common one. So it's NPK or NCK. All right, so what is this N and what is this K? Well, and it applies for both combinations and permutations. So for a permutation, NPK means the following. It's the number of permutations, okay, of n objects, okay, taken k at a time, okay. So this is like the larger group and this is the smaller group. Kind of think of it that way. So it's the number of permutations that can occur with n objects taken k at a time. So when it comes to combinations, it's still the same thing, n and k. It's a number of combinations of n objects taken k at a time. All right, so you want to be familiar with this language here. And there are formulas to permutations and combinations, but I first want to just kind of give you how to read an NPK or NCK. Okay. And by the way, for those of you out there that have like a pretty advanced calculator, something like a TI-84, TI-83, you can put in permutations and combinations, and probably a lot of scientific calculators as well. Okay, they do have these functions, although you have to kind of know how to get into those modes in your calculator to figure this out. But if you didn't have a calculator, an advanced calculator that can figure out permutations and combinations, you can do this by hand, but you need to know the formula. So that's what we're going to be doing right now. We're going to do this by hand. In other words, we can use our calculator, but we're not going to plug it into these functions. We're going to use the actual formulas for permutations and combinations. And here are the formulas. So a lot of you are like, oh my goodness, this is just like crazy stuff. What does this even mean? It's all these exclamation marks. Well, if you've never seen this before in mathematics, this is what we call factorial, okay? And it's not that difficult of a concept. So stick with me for another minute or two and you'll know exactly what this means. Okay, so here is the formula for a permutation. So NPK, right, n objects taken k at a time, it's going to be n factorial over n minus k, all of that factorial. Okay, we do all that number crunching and we can figure that out. Now, when it comes to a combination, and the problem at hand is a combination, so we're going to be using this formula here. It's going to be n factorial over n minus k factorial times k factorial. Remember, n objects taken k at a time. So how many objects are we dealing with in our problem? Remember, we have 10 students, and we're going to be taking 3 at a time. Okay, that's how many combinations we're looking for. So let's go ahead and get into the problem. So we read the problem again, and if you're not sure, let's suppose we kind of bring this right back to the very beginning, and you're like, all right, well, is this a combination or permutation? Maybe draw out, sketch out something to, like a, bunch of little stick figure students, and just say, okay, does it make a difference? Does order make a difference? And, kind of play around with it. Take a quick moment. Just, be clear about it. one way or another. And here you're gonna be like, oh no, order does not make a difference. Therefore, I'm going to be thinking combinations. So we're asking how many combinations, okay, of 3 students out of 10 students can we create, okay? And to figure that out, we need to use the combination formula, okay? So we're going to take 10 objects, okay, and we're going to figure out how many combinations taken 3 at a time, right? N, C, K, right? Given 10 students, how many combinations when we take 3 students at a time, okay? All right, so hopefully this makes sense. So you can see here we're dealing with, pretty straightforward variables. So N, okay, is going to be 10. So we're going to replace this N with a 10, and then K we're going to replace with a 3. And we're just going to plug in we're going to plug in 10 and 3 for the respective variables into the formula. Let's go and do that now. So here is what you have, okay? So it's going to be 10 factorial. You can kind of see right here how it matches up. So it's going to be 10 factorial over 10 minus 3 factorial times 3 factorial. So now we get to do all the number crunching and figure this out. And when we do, we will have solved the problem. Okay, so let's go ahead and get into the actual number crunching. So again, you're probably saying, all right, what does factorial mean? Well, let's kind of clean this up here for a second. We have 10 minus 3 factorial, which of course is 7 factorial. So now we are down to here, 10 factorial over 7 factorial times 3 factorial. What does this even mean? Well, let me go ahead and show you what factorial is. Okay, super easy. If I gave you 5 factorial, okay, what does that mean? How do you figure out the answer? All that means in mathematics is the following. Take 5 and start going down by 1 until you get to 1. So it's going to be 5 times 4 times 3 times 2 times 1. It's one big product. So whatever this number is, just start decreasing by 1, okay, and find that product. 5 times 4 times 3 times 2 times 1 is 5 factorial. Let's take a look at 3 factorial. Same thing, we're going to start with 3 and just go down by 1. So 3 times 2 times 1 is 3 factorial. So, it's pretty easy, right? 10 factorial, you're just going to start with 10, go down by 9, 8, etc. The only thing that you need to know about factorial that may not be obvious is what is 0 factorial? 0 factorial by definition is 1. Okay, so just remember that. And if you remember this and these examples, then you are now an expert in factorial. Okay, so now let's go ahead and do the number crunching here. So 10 factorial is what? Well, it's going to be 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1. And then we have 7 factorial and 3 factorial in the denominator. So, if you write this out, I'm kind of showing you this the long way here. But when you get better with factorial, you can actually, you don't have to write out all this factorial here. But what I want to show you is that here's 10 factorial. Here's 7 factorial. 7 factorial is the same thing as we look at 10 factorial. We have 10 times 9 times 8. At this point right here, we have 7 times 6. This right here, hopefully you recognize, oh, this is also 7 factorial. Okay, so this is 7 factorial, this is 7 factorial. So you can actually cross cancel all of these factors and these factors. It's one like product. Okay, so and when you get better at this with 10 factorial, for example, in this problem, you can just say, oh, that's 10 times 9 times 8 times 7 factorial. Okay, so that would be, up in the numerator. So you can just simply cross cancel those two factors. Okay, those groups of factors. But I want to kind of show you this the long way, just in case you're not that up to speed on working with factorials. Okay, so when we look at this, we're left with this right here, 10 times 9 times 8. All that divided by 3 factorial. So let's go ahead and continue on. So again, we get to cross cancel all these factors, and that leaves us with 10 times 9 times 8 over 3 factorial, which is what? 3 times 2 times 1. So now we get to do this number crunching. 10 times 9 times 8 is 720. And that's going to be divided by 3 times 2 times 1, which of course is 6. And then when you do this division, we get our final answer, 120 ways. Okay, so how many different ways can 3 students be, or how many different combinations of 3 students can be selected, from a group of 10 students? It's 120 different ways. So this is an illustration of a counting problem, in mathematics. This is very, very important concept, and it's kind of really the beginning concepts of dealing with more advanced things in probability. So if you're interested in learning probability and statistics, especially probability, you need to learn how to count, okay? And not just count basic kind of scenarios, more sophisticated scenarios. And a lot of that stuff is going to be permutations and combinations. So again, concepts that you're definitely going to see if you stick around long enough in mathematics. If you need help with, again, with permutations and combinations, I teach this pretty much at all of my levels of mathematics, in really kind of starting like in algebra. But if you're in a more advanced course like pre-calculus, of course, I'll be teaching it at a more advanced level. So if you need additional help, check out those various courses depending upon your level of mathematics. But hopefully you got something out of this video. If that's the case, don't forget to like and subscribe. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.